Hello everyone, my name is Octavio Fuentes Corro. I'm a geographer from the Catholic University of Chile and technician in Núcleo Milenio City. And my labor is to study sediment cores to find paleoseismic evidence. Through a link we've been establishing with SEASA in La Serena, there is available for us a set of different sediment cores retrieved from small andean lakes in north-central Chile, which we want to analyze to find paleoseismic evidence. And this presentation is titled Searching for Paleoseismological Evidence in Available Samples from Small Andean Lakes of north-central Chile. Lacustrine sediments can be useful as paleoseismic records. In sediment cores, we can observe deposits from slope failure triggered by earthquakes. When the materials fall into the subaqueous environment, they mix with the water and then can turn into a turbidity current. As soon as the turbidity current begins to slow down, the materials settles down. The coarse material settles down first, and the finer the material is, the longer it takes to settle. The result of this process is a deposit called turbidite. Turbidites have an important paleoseismic potential, which has been demonstrated through the lacustrine paleoseismic records of megathrust earthquakes in the rupture area of the giant 1960 earthquake in the south-central Chile. The aim is to analyze pre-existing data of sediment cores retrieved from small Andean lakes in north-central Chile. It is worth noting that this represents an opportunity in the current pandemic situation that difficults field work, and also represents an opportunity in the face of elusive coastal paleoseismic evidence in this region. My labor consists in two main tasks. The number one is to establish a link with the research team of Dr. Antonio Maldonado from SEASA to study sediment cores from the lakes they have sampled in the north-central Chile. And number two is to understand and perform sedimentary analysis techniques focused on finding paleoseismic evidence. With respect to the link with SEASA, here is Dr. Antonio Maldonado, the leader of his team. They work in the field extracting different sediment cores from small Andean lakes, which they use to make paleoecology, palynology, and paleoclimate research. Meetings have been held with his team, and different analysis of sediment has been obtained, such as reports of macroscopic analysis, and more important are the X-radiographs made into different sediment cores. These radiographs are very important. Why they are very important? Because of their application in the study of the structure of the sediments. X-radiographs and also CT scans allow the visualization of sedimentary structure that is not macroscopically observed. It is possible to observe faces with distinctive turbidite structures, for example, in the left side, in the work by Van Dale, and X-ray CT along a sediment core from the Eisenfjord reveals ripples and other faces interpreted as turbidites. Also, it is possible to observe subsediment deformation generated by seismic shaking. For example, on the right side, in the work by Monet in Switzerland lakes, we can observe faults and liquefaction structures generated by historical events on the 17th century. For final considerations, it is expected as an outcome of the X-ray analysis to designate prospect cores to perform further analysis that confirms the presence of turbidites. For example, a good analysis is the magnetic susceptibility, which depicts a distinctive pattern in the base of turbidites. Finally, it is worth mentioning that the cosmic origin of eventual turbidites will be a matter of scientific debate, because other trigger mechanisms such as floods must be discarded. And that's been all, and thank you very much for your attention.